Good afternoon, and thank you for attending this afternoon's design review. My name is Nicholas Molino, and I will be presenting to you the pasta machine that we have designed for your company. Our design is based around the fact that a conveyor will be providing the dough to the machine, and our machine will be compressing the dough and delivering it back out to another conveyor belt. Here's a little schematic of how it's going to work. The dough comes through our two rollers and out the other end. The bottom conveyor belt is set to 1 meter above ground, and this was one of our main design constraints, along with the design constraint of having the dough 1 meter wide. So we have set the conveyor belt width to 1.5 meters, and the output dough is to be a thickness of 1 millimeter. Here you see another view of our machine. As you can see, it has 2 gears with the motor on the rear gear. The top conveyor belt feeds in and back out. Here you see our overall design with reference dimensions. It is almost 2.5 meters tall, as you can see, a little taller than Tim Tebow. So it is a large pasta machine. The rollers are each 2 feet in diameter, and the bottom of the machine where it stands is 1 meter above ground. So it is a good size. For the dimensional footprint, the machine will take up about 3 meters squared of space on your floor. For power requirements, the output of the dough is to be at 5 meters per second velocity. So based on this, that is how we came up with our 2-foot diameter design for the rollers and a power output of 0.13 horsepower. That brings us to the gears, which we had to come along with 30 teeth for the gears, and we, as you saw in the previous slide, that there are 2 gears, and each of the gears have the same diameter as our shafts. Our roller bearings, we desired a reliability of 99% and 15,000 hours of life. So based on these factors, we chose O2 series cylindrical roller bearings, 25 millimeter bore, which fits perfectly on our shaft. Here's a little schematic of our shaft. As you can see, the rollers are each 2 feet in diameter. And here's our gear, and the bearings are on the outside. For our material selection, we chose stainless steel, especially since this is a food production line. We felt stainless steel would be vital to that production. With stainless steel, we're able to get a factor of safety of 263. This is great. It definitely means that the machine is going to be durable and is going to last. For our life analysis, we were able to predict that the machine will have infinite life based on the shaft calculations, the bearing calculations, and the gear calculations. Thank you very much for attending today's presentation, and we hope you will enjoy the use of our pasta machine.